Hello, today we are going to learn about linked list. First, we will start with the easy problems. So, first one, conversion of binary number into the linked list to integer. So, this was the problem in the date code, and here the given head, which is the reference node to the single linked list, and the value of each node. Each node in the linked list is either 0 or 1. The linked list holds the binary representation of a number, and now we have to return the decimal value of the number in the given list. So here they have given one linked list which contains 0 and 1. So okay, here we have to store all the values in the linked list into an array. Then what we have to do is that we have to convert that array into a string, and that string we can directly use the Python program like int of string comma 2, it will convert into binary, so then we can return it. Or else instead of taking array, we can directly store in this string. So this was the first problem, and the test case is 101. And we should take one string and a self. Let a string be empty string, and let temp value equal to head. Now while temp equal to temp plus 1. Now we have temp value, then that will be an integer. We have to convert it into string, and we should we have to add to the string. So let's add str plus equal to str of stri. Let's take stri as the string name, and now we will add that string temp dot value to that. Now we have inbuilt function that is int of binary comma 2. It will directly convert into binary. S equal to int of stri comma 2. Now return the yes. That's it. So this was the first problem. Now the second problem is remove the nth node from the end of the list. This was the median sum. Here they will give the head of the linked list, and we have to remove nth node from the end. So if they have given the 2, then we have to remove the second node from the end of the linked list. Okay. If we have 1, 2, 3, 4, 5, and we have to remove the second element, then the final output should be 1, 2, 3 and 5. So for this, what we can do is, okay, first we will traverse along the linked list and find its length. After finding its length, now they will give one value like n equal to 2. Then we should subtract that value from that, and that indexed value should be removed from the list. So we will write one remove function. Like if we pass an index of that index to that remove function, it will remove the certain index position value. So see, here I have written one code. If count equal to 1, if the length of the linked list equal to 1, then return none. Else we should find the index. Index equal to count position, I have already told you. Then we have to write some remove function. Remove index. If index is 0, for index 0 we have one condition, else we have one condition. If index is 0, then see, we have three conditions while removing the number, like removing from the index, removing from certain position, and removing from the end. Removing from the end and removing from certain position is almost similar, and removing from the starting is somewhat different. So we should write code for that, and then I have written the code for certain position and end. Okay. How I removed is, first I have traversed through the linked list. I have taken two variables, temp and temp1, and I have traversed through the linked list, and I have stopped at position 3 and position 4. Now I have interchanged the temp values of that. Done. Okay, now we will see third one. Let's do sorted lists. Okay, they will give two sorted linked lists, like 1, 2, 3, 4, 5, and 1, 3, 5, 7, like that. And we have to merge those two linked lists. First, my approach is like storing an array 1, storing the numbers of the list 1 in one array and list 2 in another array, and we can use merge sort for merging those two arrays, and we will convert that final array into linked list, and we will return the value. I think I have done this one. Okay, I have extended, and I have directly used the sort function instead of using merge sort. It will be also okay. Then I have converted into the linked list, that array into the linked list. It is very simple. Now merging of k sorted lists. This was actually hard sum in lead code. You are given an array of k linked lists. Each linked list is sorted in ascending order. Merge all the linked list into one sorted linked list and return it. Okay. They have given the linked list of linked list. Now we should I think this was okay. We can do. I will try this. So first my approach is that I will take one variable array final. I will iterate to the list, and I will append every value into that final array, and then I will sort, and I will convert that sorted array into again a linked list. So I will code it up. Let's take a linked list name final. Now iterate through the linked list for I in range, for I in lists. I in list we have list node. Okay. That list node name is I. Okay. Let's take temp value. Temp equal to head. Head is I of 1. Will it work? Okay, I will try. While temp equal to temp dot next. Okay. Now we will append the value into the final dot append of temp dot value. Now just I will see whether it is coming or not. Return final. return final. Okay, I will run the code. This node is not subscriptable. Okay, we are getting the numbers. So now we will sort the array. First we have taken the final array, that was the see. Clearly my approach is like a brute force way. First I am taking a variable array like final, and I am appending all the numbers into that array, and now I am sorting that array using sort function final.sort. Now we have now I have an array with the sorted numbers. Now I should convert this array into the linked list. So for conversion on that, let take a variable L3 equal to list node of final of 0. See, this was the head node. Head node is the 0th index, that is 1, like 1 or something, smallest value. Now let's take the iterator. Iterator is equal to L3. Now for I in range of 1 comma length of final, iter dot next equal to list node of final of I. Now iter equal to iter dot next. Now we will return L3. Let's see if it works. Done. It is working. I think it should submit. I'm going to submit, right? Okay, I have submitted. Okay, we have forgot one condition. If given list is empty, then we should return none, right? So we'll write condition if length of lists is 0, then return none. Okay, let's use one test case to test it. Okay, now I have given the length of the list as 0. Let's see if it works. Yeah, it is working. Now I will submit the code. Okay. If length of final array is also 0, if length of final is 0, if length of the final is 0, then also we should return none. And I think now it should work. Yeah, done. It was 96% faster than others. Okay, this was the hard sum in linked code, and I have just solved it. Okay, now we will go to another question. Reverse n nodes in the K2. Okay. Given the head of the linked list, reverse the nodes of the list K at a time and return the modified list K is a positive integer and is less than or equal to the length of the linked list. If the numbers of the nodes is not a multiple of K, then left out nodes in the end should remain as it is. You may not alter the values in the list node, only nodes themselves may be changed. Okay. Given the head of the linked list, reverse the nodes of the list K at a time and return the modified list. K is a positive integer and is less than or equal to the length of the linked list. If the number of nodes is not a multiple of K, then left out nodes in the end should remain as is. Okay. He will give one linked list and he will give one value. For every those value, if we give 2, then for every 2 numbers in the linked list, we have to reverse those numbers. Interesting. If he hasn't given, like if we have 5 and he have given 2, we will reverse first 2 digits and next 2 digits. We will end up with one value remaining, so we will leave that. Okay. First we will see reversal of linked list and we will come to this. Okay, I will search for reversing linked list. Okay, reversing linked list, I have done it. Okay. Here I have used 3 pointers: previous, current and next. Okay. There is another way. Let's see what if we get this number, how much score. Like its runtime is 65 milliseconds. Now I'll write another code. Let's check how much time it will take. Array. First I'm going to take one array, then we will take as temp as a head, while temp equal to temp dot next, and we will go up and write. Here we are appending values to the array. Array dot append temp dot val. Okay, now all the values will be appended into the array. Now okay, array equal to array is to minus 1. Now the array will be get reversed. Then we can return that array. No. Okay, let's see what will happen if we return that array. Actually, the return function is in the form of list node, but I have returned in an array. See, same 5 4. The answer was correct, but I have to convert this again into a linked list for them, exactly as a previous sum. L3 equal to, let's take a list node of array of 0. Next, and we will take the iterator as L3. Next we will write one loop for I in range of 1 comma length of array. Iteration equal to list node of array of I. Okay. Now iteration equal to iteration dot next. Now we will return the value of list node, head, that is L3. Now it should work. No, what happened? Only one value. Array of I iteration equal to okay, sorry. Here in 18th line I have written iter dot next equal to iter. Now it should work. No. Iteration equal to list node of array of n. Iteration dot next equal to iteration. Return list node. Equal to either dot next. Iteration dot next. Okay. Here I forgot to give iteration dot next. Now iteration equal to iteration dot next. Now it should go. Okay, it worked, but if they give empty list, then we should return none. Why none? We can return empty list. If they have given empty list, let's check if it is none, then return none. Return none. Okay, let's check whether it works. Okay, let's take an empty list as an array, as an empty list. Yeah, it accepted, so now I'm going to submit it. Yeah, it is faster, but I think it was not the right process. Memory usage is not very efficient. Now we'll move to another problem. We will see one sum. Linked list in random node. Linked list random node in deep code. Okay, given a single linked list, return a random node value from the linked list. Each node must have the same probability of being chosen. Implement the solution class. See, if the given solution get random, then given a single linked list, return the random node value from the linked list. Each node must have the same probability of being chosen. Implement the solution class. Okay. They have given the solution. This was hard, I will do it later. What if the linked list is extremely large and its length is unknown to you? Could you solve this efficiently without using extra space? Okay. It was somewhat hard. We'll do it later. LRU catch. LRU catch is very efficient when it comes to Fibonacci series. In this is also same as last one. We have more than 3 functions, so we'll skip this for now. Design skip list. Let's check if we can solve this. Let's see. No, it is also same as last one. Like it has 4 functions. I have solved this one. Reverse node in K groups. Okay, I will try this. Just now I have solved this. Okay, LFU catch, designer text editor, all-in-one data structure. These are very hard sums. Okay, we will do it. Now we will solve some random questions. Actually, I will solve medium questions in this state code. Let's go to algorithms and now set the difficulty to medium. After setting the difficulty to medium, now we will go to third page or fourth page. There we will get some good questions. Okay. Maximum swap. We will see this code. See this problem. We are given an integer. Now we can swap two digits at most once to get the maximum value. Return the maximum value number, you can get 2736. You can swap 27 as 72 and you will get the maximum. 9970. No swap. Okay. You can swap two digits at most once, not consecutive. You can swap any two digits. You will get the maximum. So my logic is if the numbers are in sorted way, then we should return same number, else we'll try to we'll pick the largest number and swap with 8th position. Like if we have 9279, we will swap 2 and 9. So for that we have to think some logic. For now I am not getting anything, so I am skipping this. And we will solve some binary search questions. Not binary search. Yesterday code forces was done. Reason 2. We will see some 2 or 3 sums from that. Tomorrow also there was a contest. Oh, today coach of is there. Coach of starters. Now we'll go to contests. There we will select yesterday's interview kit and enter. This was the second divisions. Very less people saw this. Very tough sum. Doremi is asked to test any contest. Contest I can only be tested on day I. The difficulty of contest I is AI. Initially, Doremi IQ is Q. On day I, Doremi will choose the whether to test contest I or she or not. She can only test a contest if her IQ is strictly greater than 0. If Doremi chooses to test contest I on day I, the following happens. If AI greater than Q, Doremi will feel shy, will feel she is not wise enough, so Q decreases by 1. Otherwise, nothing changes. If she chooses not to test a contest, nothing changes. Doremi wants to test as many contests as possible. Please give Doremi a solution. Okay, let's see input. On the first line we have test case, number of test cases. Then we have N and Q, which denotes N contest and Q is the IQ. So 1 and 1. Then we have the difficulty of the each contests. the number of contests and the do re mi IQ in the beginning, the difficulty of each contest. Now, in the first test case, do re mi test the only contest, her IQ doesn't increase. Okay, now we have test cases on the first line, and N and Q. N is the number of contests and Q is the IQ of the do re mi. Okay, in the first test case we have 1, 1 and 1. Okay, now IQ doesn't decrease. In the second contest we have 2 contests and 1 is the IQ. So the difficulty of the contest is 3 and 1. So 1 and 2. For that, no increase. For the second test case, do re mi test both contests. Her IQ decreases by 1 after testing contest 2. Right? In the third, let's say third test case. Third test case is 3, 1. First, her IQ is 1, and we have 3 contests from. It will test the test case 1, then test case 2. Her IQ will decrease. Do re mi test contest 1 and 2. Her IQ decreases to 0 after testing contest 2, so she can't test contest 3. One day, do re mi will not choose whether to test contest I or not. She can only test a contest if her current IQ is strictly greater than 0. Strictly greater than 0. If do re mi chooses to test contest I on day I, the following happens. If AI greater than Q, do re mi will feel shy. AI is greater than Q, she will shy. So otherwise nothing changes. So if the IQ of the do re mi is less than the IQ required for the contest, then IQ will be decreased by 1. Okay. For each test case, you need to output a binary string as your do re mi chooses to test contest I and Si equal to 0. Otherwise, the number of ones in the string should be maximum possible, and she should never test a contest with when her IQ is 0 or less. Decrease by 1, it will be 0, it will be 2, it will be 2, it will be 1. Very great bench. The third test case, 1, 2 and 1. 1, 2 and 1. Do re mi tests first contest, and contest will become 0, 0. Third test case, it will be, fourth test case, it will be 1, then how it will be 1. Okay, let's be 1. Okay, done. 1, 0. Done. For 2, it is 0 first of all. Next, same as 2, 1. Same as 2, 1. Decrease by 1, and it will be decreased. Okay, I got the logic. While iterating through the array, if Q greater than, if A of I greater than Q, then print a G, append 0 to the string. If less than, now we are going to do Koch's problem. Actually, I am using 4, so There will be about 9 problems you have to do. First, the problems are interior design, walls, past levels, the last level, easy pronunciation, yet another palindrome, largest family, maximum, median, and consecutive sort. And the code is INTRDSGN TPAPER last LE EZS speak make pal large fam mid max strings are okay. The following problems are not part of the contest and will not be counted towards your ranking and rating. These are the problems for the other divisions made available for you to practice. Click here to know more. CodeChef was created as a platform to help programmers make it big in the world of algorithms, computer programs, and programming contests. At CodeChef, we work hard to revive the geek in you by hosting a program contest at the start of the month and a smaller programming challenges in the middle of the month. This is a one-on-one style contest. This means that the problem will be partially graded. You will get score for passing certain test data. The details of the failed cases will also be visible on your solution page. You can submit solutions as many times as you would like. There are no penalties for incorrect submissions. Only one best correct submission will be considered. Bob wrote the same exam, but he marked true in each and every question on the opposite of which what Alice did. Determine the score of the Bob. Given input 1, 150, 0, 176. Output should be 0, 50, 24. There was one question in the exam and Alice answered it correctly. This means Bob will surely answer it incorrectly. Therefore, Bob's score is 0. Alice answered all the questions incorrectly, and so Bob will surely answer all the questions correctly. Therefore, Bob's score is 50. For each test case output on a new line, the score of the Bob. Let's see the solution. Alice wrote an exam containing n true or false question, each worth 1 mark, and there is no negative marking in the examination. Bob wrote the same exam, but he marked each and every question as the opposite of what Alice did. Our objective is to determine Bob's score. Given Alice has scored k marks and each question has 1 mark, thus the total number of questions attended is k. So n minus k will be the Bob's score. The time complexity is big of 1. Append 1. If equals less than or equal to, then append 1. If greater than, minus 1. If its string becomes 0, if she chooses not to test a contest, nothing changes. Doremi wants to test as many contests as possible. Okay. This was actually dynamic programming sum. I can do for the continuous, but it was a bit hard when it comes to dynamic programming. We should do only at certain times. If we have to skip some of the contests. We'll see if that condition is there or not. Okay. Is not wise enough. She can only test a contest if her IQ is strictly greater than 0. On day I, Doremi will choose whether to test contest I or not. Doremi wants to test as many contests as possible. Please give Doremi a solution. Okay. So the number of ones should be then zeros, not zeros. Number of ones should be max. So we can't do this. Okay. Search in rotated array. Okay, this was the binary search in the rotated array, which is tough. First and last position of the element in the sorted array. Let's try this. Given an array of integers nums sorted in a non-descending order, find the starting and ending position of the given target value. Target is 8, 3 to 4. Given an integer sorted in non-decreasing order, that is increasing order, find the starting and ending positions of the given target value. Okay. We should write the binary search. We should not write any algorithm from big of n. Okay, since it is sorted, we can use the binary search, but binary search is only applicable when it is, I think it has okay, binary search if it is 8. Even though binary search works, we can't tell it will work. It will find the number, but how to determine the array where the number is present in that final array? See, we can write easily in big of n, but that's not the thing. I think we can write this. Once we will check the binary search. Very long back I have learned this. Okay. If right greater than left. See, I have not learned this. In YouTube I have learned this in the channel called binary search algorithm in Python. Yeah, in Code Basics channel I have learned this. So I will just recap through it. Okay. He has one site called codebasics.com. He will Code Basics YouTube channel, and he has some account in GitHub named Code Basics. Here he will upload the code of the every video. Now we will go to that site and we'll check whether he uploaded or not. He uploaded, and okay. Now we'll take some. Now we'll use binary search for that. Okay, we have left index as 0 and right index as length of number minus 1, and mid index as 0, while left less than or equal to right index. Mid index equal to left plus right by 2, and mid number equal to numbers of range. If mid number equal to number to 5, then return the mid index here. If less than, okay, if we find that number, okay, somewhere we'll find that number. I think first we will find that out there. First I will write the code of the binary search, and I will check whether it was satisfying for let's check whether what is the output it will give if we have multiple numbers in the sorted array, but same number here multiple times repetition. Okay, now we'll define binary search, and we will pass the array as the object, sorry, what we call it, attribute. Now let's take the start as 0 and end as length of array minus 1, and let's take mid as 0. Now we will run a simple while loop while start less than or equal to end. If start is greater than end, then we will stop that, and we will return it was not found, number was not found like that. So we have to pass another attribute, that is a number that we want to search, like we'll name it as target that we want to search, and we will run a while loop while start less than or equal to end, mid equal to start plus end, we will take in a bracket start plus start value plus end value by 2. Now we will find the mid index. Let's take a not mid index, we have mid index. Now we have to find the mid value, so we will name it as mid ed. Let mid element is equal to array of mid. Now if mid element is our target, then we will return index of it, that is mid was the index. Now mid ele is the mid element. Else if mid element is greater than target, then we'll do one thing, else we'll do one thing. See, if mid element is greater than target, then if mid element is greater than target, the target, then we have to search this side. So end equal to mid plus 1, else start equal to mid minus 1. Now if no element is found in that array, we can just return that, return as number was not found in the array. We will return this. Now we will write some main function. Let's take, okay, directly we call the function binary search. Okay. First we will define an array name 1, 2, 3, 4, 5. I forgot to caps lock, sorry, number lock. 1, 2, 3, 4, 5, and we will search for, let k equal to, we will search whether the 3 is present in the array or not, and now we will call the array binary, sorry, I have not given underscore in that. So binary search of array comma k. See, now we'll see what it will give. Syntax error where equal to sorry, if mid is equal to target. Yeah, it wasn't returned anything again. We'll check again. If start less than end, if start less than or equal to end, okay, mid equal to start plus end by 2. If middle equal to array of mid, if middle equal to target, then return mid, if mid LE greater than target, then end equal to mid plus 1 as start. At least it should print not forward. See, nothing is printing here. Oh, I'm just returning, I'm not printing anything. Oh, okay, we'll write again. Print binary search of array comma k. Now we'll run this. See, it has returned 2. Yeah, 3 is found at index 2 since the index of the array starts with 0. Okay, now let's give 3 comma 3 comma 3. Let's see which index we will return first. 0 1 2 3. See, it returned the mid value. If we have 4, then what will it return? Let's see. If we have 4 3s, it returned the second returning value. Again we'll write this. We have 5 3s. It returned 4. Okay. By this logic I have understood that if there are odd number of, even though I get the logic, but it will, I think, not useful, because again we have to search for that. Okay, we will modify something. If mid element is equal to target, then return mid. Okay. We will modify like if mid element greater than target and equal to mid plus 1. Yeah, it's okay. Else start equal to mid minus 1. Okay. If the element was found, then what could be the right side and left side number of values? Okay, we'll do this. At least we get the binary search. In mathematics, the prime count function is the function counting the number of prime numbers less than or equal to some real number x. It is denoted by pi of x, unrelated to the number pi. Of great interest in number. We have binary search in recursive also. In that, we will take number list, number to find left index and right index as the attributes. If right index less than left index, then return 1. Mid index equal to left index plus right index by 2. If mid index greater than or equal to length of the number list, or mid index less than 0, return -1. Mid number equal to numbers list, mid index.